So infiltration is the process by which storm water or rainwater can infiltrate into a ground. And if you think of now how infiltration occur, let's say this is a ground surface, and then there is a rainfall. And if you look at in zoom version of here, you have soil, and storm water or rainwater can infiltrate into ground, where let me make this one. So you can say that all these rainwater will slowly infiltrate into ground. So that means you can say there is a wetting front which moves downward, and that's like water is being sucked into soil. The reason why it happens is because most of the time, if the pores are very small, there is a capillary pressure or suctions. So that means if you have a soil which is pretty dry, the moment you add a little bit drop, everything will suck into it very quickly. So that infiltrations can increase if soil is dry previously. The reason is, if soil is dry, there is less water to begin with, so any drop of water, there are more storage, so that means you can improve infiltrations. So that means you can say that infiltration is directly proportional to the water content. What's the complete saturation water content, means what's the maximum capacity, maximum storage capacity or porosity. So theta saturations minus water content initially. So the greater the difference, the more the infiltration can occur. It can also improve if there is a capillary pressure. Capillary pressure means if you have very fine particulates, the suction pressure is so high that it will pull that water inside very quickly. So this is we call capillary. Again, capillary is a function of pore size. Okay, the particle size, fine particles, more capillary. Also, infiltration decrease if you already have a wet soil, because already feel there is no incentive at that soil for infiltration to occur. So that's you can say that it's inversely proportional to the total amount of water already filled. So this is filled water. So these are the three factors. There are other factors. It also depends on hydraulic conductivity. If the soil naturally have high capacity to infiltrate water, it will have increase in infiltrations. Again, these are all related to unsaturated soil, means soil which has no water to begin with or doesn't have complete saturations. What you learn in Darcy's law is related to saturation, completely saturated soil. There is the moisture content doesn't have any role there. So that's a clear distinction. There is a question, does the total amount of infiltration increase if soil is dry, or does the infiltration rate increases if soil is dry? What I mean to say is infiltration rate changes with time. So if your soil is completely dry, so initial time the infiltration will be very high. As time progresses, the soil become wetter and wetter, that infiltration will decrease. And once the soil become completely saturated, it becomes the hydraulic conductivity of soil, or saturated hydraulic conductivity of soil. So what I'm saying is, if you plot infiltration rate at different time, initially soil was dry, it will be more like this. After a point, it becomes same as saturated hydraulic conductivity of the soil that you know from Darcy's law. So this is the concept. Now question is how we can quantify that infiltration rate, because that's exactly what we're going to put in the model to estimate how much runoff you have. There are two models people use to quantify infiltration rate. So if you see this equation here, as I said, the velocity, infiltration rate, decreases with time. You can see from this graph, initially when you have dry soil, it is high. As the time progresses, the infiltration rate decreases. And what shows here, that's the amount of rainfall happens, rainfall intensity. So why it is important? The graph, what it shows here, the soil has a certain infiltration capacity. Only when you have a rainfall, which is above the infiltration capacity of soil, then only you'll have some runoff. So another way to say is initially whatever rainfall it happens here, that infiltration rate or the amount of rainfall received is a lot less compared to the capacity of soil to infiltrate. That means all the soil that receive as a rainfall in the beginning will all becomes infiltrated into the ground. Nothing will be runoff. So the actual runoff, the rainfall that cause runoff is only this small portion. So we can call rainfall intensity or effective rainfall intensity that resulted in a runoff, which is very important because then you want to account for that much rainfall intensity when you are designing these green infrastructures. So now question is how to model this curve, how to really find this curve for different locations or different soil type. So that's the Horton equations predict. What it means that F is infiltration capacity. So infiltration capacity at any time can be predicted based on its hydraulic conductivity or the saturation steady state infiltration capacity, which is hydraulic conductivity this. So that means this is the infiltration if you continue to have a rainfall for infinite time. That means once the soil is completely saturated, this is the steady state rainfall infiltration intensity you will receive. And then there is exponential term that will count for how it decreases over time. Okay, so that's essentially F0, which is the initial infiltration rate, which is very high initially, minus the steady state infiltration rate times the exponential term, and that exponential term depends on a decay coefficient. This is what determines how quickly it will decrease over time. And then this is a time term, how the time changes with time. And this T0 is that initial time when there is a runoff happens now. Because if you see from here, T0 would be here. Because at that point, there will be some runoff. Let me see, anything else? Any question on that? And everything is pretty straightforward. So if I ask you to calculate infiltration rate, you just need to know the FC, F0, K, as well as T0. Okay, and T0 is usually given to you, and it says that only after half an hour you'll have some infiltration begin. Because I'm sorry, this is not T0. The more I incorrectly said, T0 means the time before infiltration occur. Means anytime there is a rainfall doesn't mean that there will be infiltration, because some of the rainfall can be intercepted by trees and other things. So that there is a time difference before the infiltration to begin. It's specific to different sites and will be given to you. K as well as F0 will be F0 and FC will be given to you from a table. As you can see here, those numbers are usually given based on different locations. If you search Horton equation parameters, you'll find parameters for different types of land type. For instance, here I give you examples based on different soil type. What you can see here, which is very similar to hydraulic conductivity. Sand should have very high infiltration capacity in long term. So that means you can say if you have a sandy soil, the infiltration is much higher. As you decrease the size, smaller and smaller, the steady state infiltration rate will be smaller and smaller. Clay will have the least amount. Again, these terms will be there. You just use that to answer that questions. Here is example. This is the example typically will be in the quiz. Using Horton equation, find the infiltration rate at time 2 hours for a particular type of soil, which is loamy sand. And it says that the rainfall duration is 4 hours. And for this event, it takes about 0.05 hours to reach the interception capacity. That means infiltration can only begin after 0.05 hours. So that's T0. And time, I asked you what's the infiltration rate after time T equal to 2 hours. Again, you have the equations. Ft equal to Fc plus F0 Fc. F0 is the F0 and Fc you can determine from the table given below. It's here. It says sandy loam here. And you have both SI unit as well as English unit. You can use either of them. If you put it here, inch per hour, plug all those values, you will get that answer. So what that means is your infiltration after 2 hours is become 2.69. The only way to verify whether you have a correct answer or not, check what is the F0 number. F0 number means what's the initial infiltrations, which is 3.5 hours. It has to be smaller than that number, and it has to be greater than the steady state infiltration rate. For instance, here the steady state infiltration rate is 2.6, and the one you got after 2 hours is almost near to that number. So that means within next 1 hour or so, it will become steady state. Any question?
I have a question, Professor.
Yes.
Do you think this equation will be able to deal with problems relating to puddling, so like, or ponding?
Ponding?
Yeah. So like what, or puddling?
Puddling. Okay. So no, this equation is all about how much water is going through that soil. It doesn't account for other process like storage because of puddling and all the other stuffs. This is purely about if you think of how much water will get into that subsurface soil.
Right. So like, what if there's a soil that sort of reaches its max capacity, and then any infiltration that any precipitation that sort of falls on it starts ponding over it or puddling over it.
Oh, I
and
see.
Then
Okay. You are saying,
the
can this equation predict ponding? Yes. The whole point of this.
pretty much, yeah.
Yes.
That one. Can it?
See, this equation, all it does, it determine this curve here. Anything above that curve, any intensity, those become ponding. But how much that ponds, it all depends on the catchment area as well as the site descriptions.
Right. So as long as the rainfall intensity is over that curve, then
Yes.
we can expect ponding.
Yes. Yeah.
What if it's a case where the rainfall intensity is less than the curve, but the duration is really high? Can we expect ponding then?
No. You are saying the infiltration rate is higher than the rainfall intensity, right?
Yes.
Yeah, then you don't. That means any water comes here, that time will all infiltrate into the ground.
Right. Perfect. Thank you, Professor.
Mm-hmm. For instance, what you're saying is here, in this case, at the end, this area, where infiltration rate or infiltration capacity of the soil is more than the rainfall intensity received at that time. So there will be no ponding at that time.
Right, right.